Hello students. In continuation with the chapter alcohols, we will discuss esterification reaction. When alcohols are heated with carboxylic acid in the presence of concentrated sulfuric acid as dehydrating agent, esters are formed. This reaction is known as esterification. Okay, carboxylic acid such as RCOH reacts with alcohol. General formula is RO-OH. In the presence of sulfuric acid, it is acts as dehydrating agent which removes moisture or water molecule. You are going to get ester. This reaction known as esterification. Here you can eliminate water like this. OH from this carboxylic acid and H from alcohol, you are going to get an ester, and sulfuric acid is added to remove ester. Otherwise this esters and reacts with water and you are going to get carboxylic acid and alcohol. Backward reaction takes place too. If water molecule is eliminated, removed by using dehydrating agent such as sulfuric acid. Dehydrating agent means the agent or the chemical which removes moisture or water molecule. If H2O or water molecule is removed, then you are going to get ester. This reaction known as esterification. Example, CH3COOH. This is ethanoic acid or acetic acid. Ethanoic acid or acetic acid, and this is ethanol, NOL, ethanol. You are going to eliminate a molecule of water like this, so you are going to get an ester CH3COO C2H5 ethyl acetate ester, ethyl acetate. This is ester plus a molecule of water. This reaction known as esterification. Here we have to make a note of this particular reaction. These esters, they have fruity smell. Hence, esterification reaction can be used as a test for carboxylic acid. Then number 2, during esterification reaction, already I have shown this one, the OH group of acid combines with the H of alcoholic group forming water like this. Suppose this is carboxylic acid RCOH plus suppose this is alcohol, already we have discussed ROH. Yes, OH group of acid, OH group of acid combines with H of alcoholic group forming water. But this is R dash, you're going to RCOOR dash, RCOO R dash plus H2O. So elimination of water molecule takes place like this. And this reaction is reversible. Okay, if water molecule is not eliminated, and you are going to get carboxylic acid and alcohol back, so this reaction is reversible. Therefore water is removed as soon as it is formed. As soon as water is formed, you have to eliminate this, otherwise you will not get that ester. Backward reaction takes place. Now let us discuss oxidation reactions of alcohols. Generally, all alcohols on oxidation using strong oxidizing agent, they give carboxylic acid as final products. But there is small change. Primary alcohols on oxidation, first they give aldehyde, which on further oxidation gives carboxylic acid with the same number of carbon atoms. Whereas secondary alcohols on oxidation gives ketones, which on further oxidation gives carboxylic acids with less number of carbon atoms. Tertiary alcohols, they doesn't undergo oxidation reaction, they are having resistance towards oxidation reaction. If drastic conditions are applied, tertiary alcohols forms ketones with less number of carbon atoms, which on further oxidation with under drastic condition gives carboxylic acid even with lesser number of carbon atom. This is the oxidation reactions of alcohols. Now let us see the primary alcohols on oxidation using strong oxidizing agents such as uh, alkaline KMN4 or acidified potassium dichromate. They form aldehydes which on further oxidation, but here the reaction doesn't stop. Aldehydes, they undergo further oxidation to form carboxylic acid as final product. Okay, RCH2OH or CH2H, this is primary alcohol. This represents primary alcohol undergo oxidation. It loses a molecule of water and you are going to get aldehyde which on further oxidation gives carboxylic acid. Example, when ethyl alcohol C2H5OH, this is primary alcohol, ethyl alcohol undergo oxidation in the presence of alkaline KMnO4, in the presence of alkaline potassium permanganate. Alkaline potassium permanganate undergoes oxidation. You are going to get acetic acid with same number of carbon atoms, CH3COH. Number of carbon atoms present in alcohol is 2. Here also it contains 2 carbon atoms plus H2O. This is acetic acid or ethanoic acid. If oxidation reaction is carried out by using milder oxidizing agent, then we can stop the oxidation reaction at aldehydic level or even ketonic level. Now let us discuss the oxidation using mild oxidizing agents such as anhydrous chromic oxide or PCC, that is pyridinium chlorochromate. They convert the alcohol into, or they stop the reaction at alcohol or aldehydic level or ketonic level. Oxidizing agents like anhydrous chromic oxide, that is CrO3, or pyridinium chlorochromate, in short it is called as PCC. It is complex of chromium trioxide with pyridine and HCl. Oxidize alcohol to aldehydes or ketones. As these are the mild oxidizing agents, we can stop the reaction at aldehydic or ketonic level. Now let us see the example. RCH2OH or CH2OH. This is primary alcohol. Primary alcohol is subjected to oxidation by using PCC, pyridinium chlorochromate. We can stop reaction at aldehydic level. This is an aldehyde. Example, butane 1-ol or 1-butanol, CH3, CH2, 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 butane 1, 2, 3, 4, CH2. This is butane 1-ol or 1-butanol. If this is subjected to oxidation by using pyridinium chlorochromate, you are going to get CH3, CH2, CH2, CHO plus H2O plus H2O. This is butanal. Na L-butanol. Here, as this is mild oxidizing agent, we can stop the reaction at aldehydic level. Now, primary alcohols on oxidation gives aldehydes. Now let us see the reaction with secondary alcohol. Secondary alcohol is having general formula RCH OH R dash. If it undergoes oxidation, if it is subjected to oxidation using mild oxidation, let us consider here CrO3. You are going to get a ketone. We can stop a reaction at ketonic level plus H2. This is a ketone. Here reaction doesn't proceed. Reaction stops at ketonic level. Example propan-2-ol CH3 CHOH. This is secondary alcohol. Propan 2-ol. This is secondary alcohol. Example propan-2-ol undergoes oxidation in the presence of CrO3. You are going to get propanone, ketone. Propanone, that is a ketone plus a molecule of water. If mild oxidizing agents are used, secondary alcohols on oxidation forms ketones and a reaction stops at ketonic level. If strong oxidizing agents such as alkaline KMnO4 or acidified potassium dichromate solution is used, then secondary alcohols undergo oxidation to form carboxylic acids with a fewer number or less number of carbon atoms than that of alcohol. Let us see one example. 2-propanol CH3 CHOH CH3. The common name is isopropyl alcohol. Propan 2-ol undergoes oxidation forming alkaline KMnO4 solution. You are going to get acetic acid CH3 COOH plus CO2 plus 2H2O. Here alcohol contains 3 carbon atoms. This acetic acid contains 2 carbon atoms. Okay, the alcohol, secondary alcohol forms carboxylic acid with less number of or fewer number of carbon atoms. This is about oxidation of alcohols. Now we'll discuss dehydrogenation reactions of alcohols. Dehydrogenation means removal of hydrogen. When vapors of primary alcohol, I will write the formula of primary alcohol. RCH, general formula of primary alcohol is RCH2OH. This is primary alcohol. You have to take vapors of this in gaseous state. Okay, when vapors of primary alcohols are passed over copper catalyst at 573 Kelvin, 300 degrees centigrade, 573 Kelvin, dehydrogenation takes place, means removal of hydrogen molecule takes place. You are going to get aldehydes. RCHO plus a molecule of hydrogen is eliminated. This is aldehyde, and this reaction is known as dehydrogenation. This reaction is known as dehydrogenation. Now let us see the example. When vapors of ethyl alcohol C2H5OH, C2H5OH, this is ethyl alcohol, When vapors of ethyl alcohol, this is primary alcohol, passed over copper catalyst maintained at 573 Kelvin or 300 degrees centigrade, you are going to get CH3CHO acetaldehyde, CH3CHO plus hydrogen gas. This is acetaldehyde. Acetaldehyde. IUPAC name of this is ethanol. Ethanol, NOL, and this is ethanol, NaL. Okay, this is about the dehydrogenation reaction of primary alcohols. Now let us see the dehydrogenation reactions of secondary alcohols. Number 2, vapors of secondary alcohol. General formula is RCH OH R dash. This is secondary alcohol. Take vapors of secondary alcohol, pass it over same catalyst copper at 573 Kelvin 300 degrees centigrade. You are going to get ketone or CO R dash. You are going to get a ketone plus hydrogen gas is liberated. This is another example for dehydrogenation reaction, and this is general reaction. Now let us see the example. 2-propanol or isopropyl alcohol. 2-propanol or another name is common name is isopropyl alcohol. CH3 CH OH CH3 2-propanol pass vapors of 2-propanol through copper catalyst maintained at 573 Kelvin. You are going to get ketone, acetone plus hydrogen gas. This is propanone or common name is acetone. This is example for dehydrohallucination of secondary alcohols. Now let us discuss about tertiary alcohols. Primary alcohols on dehydrogenation gives aldehydes, whereas secondary alcohols on dehydrogenation gives ketones, but tertiary alcohols do not undergo dehydrogenation when passed over heated copper catalyst. For example, I will write CH3C, CH3, CH3. Wait, this is tertiary alcohol. Tertiary alcohol. This is tertiary butyl alcohol. If it is passed, vapors of this is passed over copper catalyst at 573 Kelvin. Here it does not form either aldehyde or ketone. It does not undergo dehydrogenation. Instead, it undergo dehydration. Here, a molecule of water is eliminated. Because here the carbon which contains OH group does not have hydrogen atom. Hence, hydrogen gas is not liberated. Here will end with an alkene, CH3C double bond CH2 CH3 plus a molecule of water. This is 2-methyl propene. 2-methyl propene. Okay. As tertiary alcohols do not undergo dehydrogenation when passed over heated copper catalyst, as they do not contain hydrogen on carbon containing this OH group. Instead, they undergo dehydration. This reaction involves cleavage of. This reaction involves cleavage of carbon oxygen bond. When this tertiary alcohol is passed over, for example, tertiary butyl alcohol is passed, vapors of tertiary butyl alcohol is passed over copper at 573 Kelvin, you are going to get an alkene, that is 2-methyl propene. And this is exceptional case. Now we'll discuss biological oxidation of methyl alcohol and ethyl alcohol. Methanol and ethanol in the body are oxidized to aldehydes by the enzyme alcohol dehydrogenase. Methyl alcohol or methanol and ethanol, if these are consumed, then the enzyme alcohol dehydrogenase oxidizes these into corresponding aldehydes. If methyl alcohol is there, it gets converted into formaldehyde. Ethyl alcohol is there, acetaldehyde. Then these aldehydes undergo further oxidation. They undergo further oxidation to form carboxylic acid. If methyl alcohol is there, you are going to get methanoic acid. Methyl alcohol is there, yes, it gets oxidized to methanoic acid, HCOH. If ethanol is there, it gets oxidized to acetic acid or vinegar. If denatured alcohol, if human being consume denatured alcohol which contains mixture of both methyl alcohol and ethyl alcohol, methanol or ethanol, methanol is oxidized first to methanol formaldehyde, then formic acid, methanoic acid, which may cause blindness. This cause blindness. Excess concentration is there, definitely you are going to get blindness or death will occur. Okay, if any human being consume the denatured alcohol which contains methyl alcohol and ethyl alcohol, then he may end with either blindness or death. In such cases, the patient is treated with intravenous infusion of dilute ethyl alcohol. Means dilute ethyl alcohol is given. The enzyme alcohol dehydrogenase is having more affinity for ethyl alcohol. It converts ethyl alcohol into aldehyde, then into carboxylic acid. If more quantity of ethyl alcohol is there, it does not react with it because it is having more affinity for ethyl alcohol. Hence, any person, human being, if he consume denatured alcohol, then the excess of intravenous infusions of dilute ethyl alcohol is given such that the alcohol dehydrogenase convert ethanol into acetic acid and prevents the formation of formic acid. This is about the biological oxidation of methanol and ethanol.